Welcome to DS 630 machine learning class at the St. Peter's University MS in Data Science program. So here today I want to introduce you to our general course syllabus. Then first thing you should be aware, you should have some understanding of statistics, algorithms, and data structures. And ideally, you should have programming experience previously, either in Windows or Mac operating systems. One thing you should be aware, um, we're going to use Python. So I hope you already have some exposure. If not, you should spend more time on the basic Python programming so that you can keep along with this course, because we focus more on algorithm itself. Meanwhile, we are going to discuss how to implement the algorithms in Python as well. So in terms of the course description, machine learning is a science, or oftentimes people call it art, of programming on computers so that they can learn from data. It is a field of study that gives computers the ability to learn from experience without being explicitly programmed. Pay attention here, we specifically says the computer will be able to learn from the experience, not that you give some rules that computer would just follow the rules or tasks, right? So that's really the key, that computer program is able to learn from the experience. And this course covers the theory and practical algorithms for machine learning. Major topics that we are going to discuss include classification, decision trees, support vector machines, ensemble methods, neural networks, and deep learning. So you can see that the first part of the course will focus on things like classification, decision trees, and random forest. And then second part will be focused on neural networks and deep learning. Students will have opportunity to experiment with machine learning techniques, especially using Python, and apply them to solve selected problems in the context of a term project. We're going to discuss a term project shortly in a separate video so that you get a sense on what we're planning to do. In terms of the course learning outcomes, mainly have four outcomes. Number one, you should understand the machine learning landscape, meaning what's out there. Number two, learn theory and algorithm for key machine learning algorithms, such as what we just discussed: classification, decision trees, random forest, neural networks, etc., etc. Number three, know how to apply machine learning theory and algorithms to practical problems. You have to apply your understanding of the theory and algorithms to real business problems. Number four, understand and explain machine learning application output and results. In terms of the assignments and grading, here is the breakdown and distribution of different components. If you take a look, first thing that you need to remember, you should be doing some sort of discussion and participation in the Blackboard system every week or every 2 weeks. It really depends. So far, for example, for the first 2 weeks, you would have two separate discussion topics. And then you should be aware that you should be finishing your primary discussion by the end of Friday, to see that you should have some sort of substantive post that would be able to really discuss the topics that we laid out. For the first week, it's kind of a simple just introduction and whether you have any background on machine learning. But going forward, it's going to be a little bit more involved. And then other than that, you should have some response to your classmates' discussion, and or feel free to discuss other relevant topics that you are willing to share. So in terms of the breakdown, those two, for the one post that you post, you get around 10%, and the other one, in terms of interaction and respond to your fellow student, you should you would be able to get another 5%. And then second thing is assignments. We will have roughly around 7, so far I planned for 7 equally weighted assignments that accounts for 35%. So you should be expecting around 5% for each homework. And then we would have a midterm exam that accounts for 15%, and a final exam that accounts for 15% as well. For those two exams, it would be more like quizzes to help you to understand what you have learned so far, and what would be the case theory or algorithms you should have mastered. So that's those two. And then last one is the project description. And then I'm going to share the project description later with the detailed course plan. And then that's the distribution in terms of the assignments and grading. Next thing you should be aware is the required text. It is hands-on machine learning with scikit-learn, Keras, and TensorFlow. Concepts, tools, and techniques to build intelligent systems. That's written by Aurélien Guérin, and it is a second edition. Just remember, it's a second edition that was published by in 2019. This textbook is really a good textbook. You should appreciate reading the textbook all the way along, at least once. Most likely would be multiple times, even going forward when you are working in the field in the real work, you probably would use this as a reference. Then here you can see I also provided a couple of supplemental texts and materials that would help you to study the machine learning. So one is a Python tutorial that more like help you to get started. Next thing is Python data science handbook. That's a different textbook more on Python and data science. Here is a course outline. You can see that the idea is really to kind of follow the textbook very closely. Majority of this you would probably soonly realize that's different chapters in the textbook. So for the first week, you should focus on how to set up your environment and would be able to run simple command and read the first chapter of the textbook, the machine learning landscape. It's very good discussion on the breakdown of machine learning, especially on what is supervised learning and what is unsupervised learning. For the second week, you should be looking at end-to-end machine learning project. At the end of the semester, what you really need to do is to know how to build an end-to-end machine learning project. And then on top of that, I put in this classification, which is one of the algorithms in machine learning that you should get started and get a handle on it. And then followed by many other different machine learning algorithms in week 3, week 4, and week 6. You can see so far anything that beyond anything prior to week 6, a lot of these are supervised learning, And then next thing that you would be have exposure to would be anything after um, section week 8, 9, and 10 would be on neural networks and deep learning. That would be something that you would be really interested in going forward. And followed by the final exam and final project. So here is the basic rules for the school. And then I also want you to be aware you should definitely follow academic integrity that is specifically specified in the university policy. I think it's important to make sure that you don't do anything that doesn't make sense, like cheating, forgery, dishonesty, plagiarism, or copyright infringement, impersonation, and collusion in dishonest acts to undermine the university's education mission. So make sure that you do the work on your own. It's okay to discuss with your fellow students, but you should work on it on your own. And then it's okay to reference some interesting code online, but you can't just copy the code from anyone else's work. So that's something that you should definitely pay attention to. This actually wrap up my discussion on the course syllabus, and then you should feel free to reach out to me if you have any questions. Thank you.